Okay, good afternoon, everybody. Um, I'm gone again today at the same conference I was at yesterday. So today is going to be kind of a review of this week. I think the other classes are taking a quiz today, but you're just basically doing a review that would cover that same stuff that's on the quiz since I'm not here. So I just want to take today to kind of go over what we've talked about this week, kind of do some examples of some of the different questions you're going to see, and then you are going to have a review over this content to kind of finish out the day um, and get a little bit of practice before we start in on something new on Monday. So let's just take a quick look here at some of the topics that we've covered, and then we'll do some examples. So we've got the triangle inequality was the first thing we talked about. That was the activity with the straws and how if I take a triangle, you should have all this in your notes, by the way. If I take a triangle and look at the sides that make it up, the two shorter sides, A plus B put together, has to be bigger than C, right? There's no way that I could have two sides that make a triangle with C and they not be at least a little bit longer than C is. The triangle sum has to do with the angles of a triangle. So if I put angle 1, angle 2, angle 3, I know that if I add those up, angle 1 plus angle 2 plus angle 3, I get 180 degrees. The exterior angles, this is the one that you don't really need to know, and I'll talk about that more in a little bit. But if I've got these two angles here, which are called the remote interior angles, they add up to be the same thing as angle 3. So 1 plus 2, I should say angle 1 plus angle 2 is equal to angle 3. That one is one that you don't really need to know, but is kind of nice. And then the side angle inequality says that bigger sides are always across from bigger angles. So if I've got like up here, C is the biggest side, this one would have to be the biggest angle. And if, for example, angle 1 and angle 2 were equal, those two sides that are across them would also have to be equal. Bigger sides are across from bigger angles, smaller sides are across from smaller angles, equal sides are across from equal angles. So with this kind of activity or kind of stuff that we're learning about here, simple questions you could see are just, giving you a triangle and saying, okay, this one's 50, this one's 80, what's that one? And we would know, well, I would know that 50 plus 80 plus x has to be 180. And if ever I'm trying to figure out what's missing, most of you are not going to write this equation, but if you're ever trying to figure out what's missing, you're subtracting. I'm going to take 180 minus 50 minus 80, and I'm going to get 50 left over. I would do that on a calculator. I've got mine off to the side here. All right, you can see Desmos. That didn't work when I pulled it over, but I've got it off to the side here so that I can do my math. Don't try to do that all in your head, especially if the numbers aren't super nice. From there, we can combine things together, right? If I have a triangle that looks like this, and I tell you that these two sides are equal and this angle here is 40, right? Could I figure out what that angle is? Well, anytime we're using the triangle sum conjecture, we always want to know all of the angles. We want to have something in there for all angles, even if it's a number or a variable. And so what we would know here is if I've got two equal sides, well, if their two sides are equal, the two angles straight across from them have to be equal as well. So this one is also x. Now I can write that equation. 40 plus x equals 180. Right? 40 plus 2x equals 180. And so I can subtract 40, 2x equals 140, and divide by 2, x equals 70. Again, some of you are going to be able to do that without an equation, but if it helps you to do an equation, you do the equation, right? We do what we need to do to help us get through the problems, right? If you could say, oh, I know these add up to 180, so take away 40, split it into two equal angles, you're doing the same math either way. Other angles, other questions we could have. The exterior angle questions. If I tell you that this is 30 and I don't know, this one is 60 and you want to find that one. If you remember the exterior angle conjecture says that, or theorem, I think is what I said, those two angles add up to that angle. So I could say 60 plus x equals 130. That's using the exterior angle theorem. And that's a pretty easy equation to solve. I just take away 60 from both sides, and x is 70. Now, the other way you could do that without the exterior angle theorem at all is I could use a combination of things that I know. If this angle is 130, can I figure out what that angle is? Well, I absolutely can, because those are a linear pair. If I take 180, because a linear pair adds up to 180, and subtract 130, I get 50. So that angle there has to be 50. Right? We need to still know all that stuff. That's from unit 2, from the last unit. Then I can use my interior angles and say, well, x plus 60 plus 50 equals 180. Now I'm using the interior angles of the triangle, and I can take away 50 and take away 60, and I still get I'm going to get the exact same answer there, right? I'm still going to get 70 for x. Other examples we could have, let's do one with the side angle inequality, the kind of just the basic side angle inequality, right? If I give you this picture and I say that's A, that's B, that's C, and we're going to put 80 there, we're going to put 70 there, which leaves me putting 30 there. Right, those angles showed out to 180. Question you might see here is order the sides from smallest to biggest. And we're not just looking at them and seeing which one looks smaller or bigger. We got to be a little more careful than that. Our rule here says that if I find the smallest angle and go straight across, this side here is the smallest. And so that is side AB. If I find the next smallest angle and go straight across, that's my next smallest side. So the middle side here is going to be AC, putting the segment symbol over the top. And the biggest angle straight across, that's my biggest side, BC. Okay, and that works in reverse too. If I give you the side lengths and you want to put them in order, find the smallest side, go straight across, that's the smallest angle. Finally, some algebra type questions, right? Something simple might be something more like this. If I tell you that that one, and that one are all equal, and then I give you that this one has to be 5x plus 10. Right? There's a couple of ways you could do this. Most of you, I think, are probably going to look at this and say, oh, if all the sides are equal, all the angles are equal. So I can divide 180 by 3, and I get 60. So each angle in this problem has to be 60 degrees. Now, since I know this angle is 5x plus 10 and it's equal to 60, I can set up an equation and solve it that way. So I can subtract 10, 5x equals 50, divide by 5, x equals 10. That's one way to do it. That's probably what I would do. There are other ways you could go about this. Feel free, this video will be on Canvas if you're watching on the board. You can go back and pause this and slow it down too. If I know that these are all equal, there's nothing stopping me from also putting 5x plus 10 here and 5x plus 10 here, because I know those are all equal. If the sides are equal, the angles are equal. Now I can say, well, all those angles added up have to equal 180. 5x plus 10 plus 5x plus 10 plus 5x plus 10 equals 180. This one's going to be a little bit longer, but you're going to see what happens here. 5x, 5x, and 5x makes 15x. 10, 10, and 10 makes 30. And it equals 180. I subtract 30 and get 15x equals 150. And then when I divide by 15, I still get x equals 10. The nice thing about this is there's a few different ways that you could think about these questions, and you're still going to get the same answer as long as the things that you put together to find the answers are actually true. All right? So on your worksheet, you've kind of got a few little examples of that. Some of them are equations, some of them are not, some are just numbers. But you've got the rest of the time to work with this, and I will make sure that I leave answer keys for worksheets with the sub and posted on the Canvas page so that you can see those. I'll see you on Monday.